Hey guys, we're going to do our video for our lesson 12 group problems today. Question 1 is the matching list of terms. Question A says, which of the terms describes or is an example of a regulatory protein? We said the activator, inhibitor, repressor, inducer, and cap. Part B says, which of the terms describes or is an example of a small effector molecule? That would be allolactose and CAMP. CAMP. Question C asks us, which of the terms describes or is an example of a sequence found within the DNA? And we said the operator, the -10 and +1, which are part of the promoter, the LAC-Z and the LAC-A genes. Question D, which of the above is not involved in the LAC operon? The only one that we found was CAMP, CAMP, because that exists in the cell. Adenylyl cyclase is a whole different enzyme. So CAMP was our answer for part D. Part E, which of the above is the example of a structural gene? That would be LAC-Z and LAC-A.
Hey guys, for question number 2, to fill in the blanks. For question A, the LAC operon is regulated by 2 inducers. That would be the allolactose and the CAMP or CAMP. For B, the binding site for sigma factor and RNA polymerase is called LAC-P, while the CAP site is the binding site for the activator that regulates the LAC operon. For C, the enzyme adenylyl cyclase converts ATP to CAMP. For D, the -35, -10, and +1 sequences are found within the LAC promoter portion of the LAC operon. For E, the LAC-I gene encodes for the LAC repressor, while the LAC-Y gene encodes for lactose permease. For F, attenuation can regulate gene expression in bacteria by causing transcription to terminate prematurely. And for G, an E. coli strain that contains 2 copies of the LAC operon is called a merozygote strain. Moving on to question 3. This is one where we have to tell if we'll have the blue E. coli cells or not. For question A, we said not blue because not blue because IPTG is absent. For B, we said it will be blue because we have the X-gal being there and we have IPTG there, but the glucose is not there. For C, we said not blue because the X-gal is absent. Without that, it's not going to be blue. For D, we said not blue because glucose is present. And for E, we said not blue because the X-gal is absent.
For question 4, we were talking about defective parts of the LAC operon and E. coli strains. So, and we need to compare whether these are constitutive, inducible, or non-inducible expression of the LAC-Z gene. So for part A, this is a completely normal functional LAC operon, and we call it inducible. Part B, we have a faulty repressor. So the IAS up top is a repressor that binds to the operator, but not allolactose, which means it will bind to the operator indefinitely, making this a non-inducible gene. You can't run the LAC operon if you have an IAS. For part C, on the chromosome, we have a defective promoter and a defective operator, as well as a defective operator on the plasmid. So defective operators cannot be bound by repressors, and if something can't be repressed, it's going to be perpetually running. Part C, we said it's constitutive. It will constantly translate the LAC operon. Part D, we have a defective repressor on the plasmid. We called D non-inducible because the defective repressor from the plasmid can bind the operator on either the chromosome, and no matter where it binds, the defective repressor will bind and stay bound. And therefore, it will be non-inducible. We can't transcribe. Part E, we have a defective repressor on the chromosome and a defective operator on the plasmid. So normally, a defective repressor will bind an operator and never let go. In this case, the defective operator on the plasmid can't be bound by anything. And so we can kind of ignore the defective repressor, call it constituted because of the broken operator. It's just going to keep transcribing. So that's it for number 4.
Finally, for number 5, for the E. coli genotype, we have with lactose and without lactose. For A, we have a, what's the word I'm looking for? Defective, that's the word I'm looking for. Defective repressor and a defective promoter. So you're not going to get any yellow in either of the two. So both with lactose and without lactose are going to be 0. For B, you have a defective operator. So it's just going to keep running. So you'll have 1 and 1 for with lactose and without lactose. For C, in the plasmid, you have a defective operator. So with lactose, you're going to get 2, and without lactose, you're going to get 1. For D, you have a defective repressor in the chromosome and a defective promoter in the plasmid. So you're going to get 1 with lactose and none without lactose. And then for E, you're going to have none in the lactose, in the 2 with the lactose, and then 1 without the lactose because you have a defective repressor in the chromosome and a defective repressor in the chromosome. Thanks for watching, guys.